Welcome to day 14 and the start of our final phase. So deployment and scale is the next phase. And we have built an incredible event-driven observable microservices architecture. But right now it relies on Docker Compose. And you know that Docker Compose is fantastic for local development. And of course, sometimes you can use it in production. In fact, I use it in production without Kubernetes, but it only, of course, runs on one machine. And if that machine crashes, your business is dead. You can hop in and revive it, but yeah, you know what I mean. So to go to production and you have the time, the team, the money, we need to span our application, okay, across multiple servers. And this is what you would do if you had all available resources. And yeah, we need an orchestrator that can self-heal, scale up when traffic spikes, and route requests dynamically. So today we shall leave Compose behind and deploy our user service into Kubernetes. Before Kubernetes can run our app, it needs the Docker image. In a real production environment, we would push this to a cloud registry like AWS, ECR, or Docker Hub. But for today's local Kubernetes setup, whether you're using Docker desktops built in Kubernetes or Minikube, I think it has built in Kubernetes or Minikube. Okay, we just need to build the image locally so the cluster can see it. So, and for this, you need to install Minikube, you need to install Docker desktop, you need to have Kubernetes, okay? In case you need to do that, you can look out on my channel in the playlists. There's a playlist I have on Kubernetes, and it has a section where I install Minikube and everything you need to run Kubernetes. So I have a command that I'm going to paste. Okay, it says docker build -t user service latest -f services user service docker file. Okay, it is simply building, okay, the user service. So -t simply is the tag called user service latest, and the Docker file that we want to build the image from is in services, user service, and then the Docker file. Yeah, and period, I guess, refers to the current working directory. So I'll hit enter and give it some time. Okay, that was fast enough. In Docker Compose, we wrote one big YAML file, but in Kubernetes, everything is going to be more modular, I can say. And we define our infrastructure using what is called manifests. So the first thing we're going to create is a deployment. In Kubernetes, a deployment job is to make sure that your application is always running. We don't deploy containers directly in Kubernetes. What we deploy are called pods. So a pod is simply a wrapper around your container. And we tell the deployment, I want exactly 2 replicas of the user service running at all times. If one crashes, the deployment will instantly spin up a new one to replace it. So I'll reduce my terminal, and then at the root, I want to create a new directory. I'll call it K8, okay, for Kubernetes. I want the S to be lowercase. So K8, why can't I change it to lowercase? Okay, like that. And then inside, I'm going to create a file named user-api.yaml, user-api.yaml, like that. And I'll paste configuration. Okay, so yeah, this is how it's gonna look like. Okay, maybe I can remove some, but let me leave it. Okay, yeah, if in case of anything, I'll fix. Okay, this is supposed to be a comment. I don't know why it did not pick it up. Yeah, now it looks okay. All right, so like you can see, the name is called user service deployment. How do you know that it's a deployment? By line 3. Okay, so line 3 says the kind is deployment. And then I talked about the replicas. this line, okay, ensures that Kubernetes will ensure to create 2 instances, okay, of our user service. And then down here, we talk about and specify the container, okay. Remember, we created a container with a tag user service latest. Then the image pool policy will say never, okay. So we are saying use the local image we just built, and the port is 8000. And of course, right now we are just temporarily reverting to SQLite just to prove the FastAPI pods can spin up without getting bogged down in deploying a Kubernetes stateful set for Postgres today. Okay, let's not get into that. Yeah, and of course, in a real cluster, we use secrets. Okay, we use Kubernetes secrets. For now, we're just hard coding the value here for demo purposes. We have 2 pods running, but there is a problem. Pods are immortal. They die, and when they are replaced, they get brand new IP addresses. So if the API gateway tries to talk to a pod directly, the IP will constantly change and break. To fix this, we create a Kubernetes service, and a service simply acts as a permanent static load balancer. So it sits in front of our pods, intercepts the traffic, and round robins the requests to whichever pods happen to be alive at the moment. So in the user API.yaml, I'm going to paste some configuration. Again, if you want to understand Kubernetes, I have a whole playlist on learning Kubernetes. Please check it out and have a look. So this is what we're going to deal. Okay, so you can see the kind is service, metadata user service. Okay, and the type is node port. In that playlist, I cover everything. So this exposes the service so we can hit it from our browser. Okay, and yeah, this is cool. And yeah, let's move on to now applying and verifying. So we have written the code, and now we have to hand the blueprints to the cluster using the Kubernetes command line tool kubectl. Of course, like I said, look at my playlist of Kubernetes, watch it and learn from it. And maybe one thing I forgot to show you, but there's a comment for it, is that we tell the load balancer that this configuration saying app user service says this tells the user service exactly which pods to load balance. Okay, as simple as that. So I'm going to expand my terminal. I think I need to, let me stop Docker Compose for now. Okay. Okay, taking some time. And then I'll go back here and clear my terminal. And I'll say kubectl. Again, if you want to know how to get kubectl, check out my playlist on Kubernetes in the playlist section of this channel. You'll have it. Kubectl apply -t shall say k, this lowercase k8 / user service dot YAML. Okay, these things are now down. You can now hit enter, and it says unknown shorthand flag. It's supposed to be -f. Okay, -t is for Docker when you're creating an image. So saying error validating. Okay. I think it was trying to look out for Minikube. I don't want to turn off validation. So let me create a new tab or terminal and say Minikube start. Okay. This is not like a Minikube kubectl Kubernetes tutorial. You can go ahead and learn from any tutorial or from the playlist on my channel. Okay, so it says kubectl is now pre-configured to use Minikube cluster. All right, let's go ahead and clear and apply. Okay, it says error when creating deployment in version 1 cannot be handled as deployment, strict decoding error, unknown field spec dot selector. Okay, it's supposed to be selector. Spec dot selector. Wow. What have I done? All right. But even then, how they end up doing this? So I'll edit and add a C. Okay, save. Actually, when things happen, maybe going forward, I should just be using AI. Actually, I'm going to create AI engineering content soon after doing system design. Look at this. It says deployment created, service, user service, and change. Yeah, this is nice. So now the next thing I want to do is try to view the running pods. I will say kubectl get pods and hit enter. Okay. Yeah. So you can see there's an error. It says user service deployment. It says error image. It never pull. Error image never pull. Okay. And at least we see that we have two distinct services, okay, or pods. So one is a service, but we have two copies or two replicas or two instances of it. So let me clear. Okay, maybe give it some time. Sometimes you have to wait because maybe it's still, but this is an error. Okay, so let me figure it out. So as the potential fix, I want to run this command minikube image load is a service latest to push, or what's the right word, to load the user service image into the minikube cache or its environment. So let me hit enter. Did I do that? Okay, saying exiting due to home permission, save to dark, caching images. All right, permission denied. Let me try to do that using sudo. Okay, then try to enter the password. Hopefully this gives success. Right. Okay. Whatever it's doing, let's wait. In fact, I think there is another way where you can tell your terminal to build images directly inside Minikube's environment instead of your PC or Mac environment. But anyway, no need for that. Let's leave that. Okay. This is not a Docker or Kubernetes tutorial. So let's try again. I'll clear my terminal and say kubectl get pods. Okay. Yeah. Now life is good. So you can see status running and they are ready and none of them has restarted. So let me try to go to the browser. Then I'll go to localhost 3001/docs. Okay, says site can't be reached. We can use port forwarding to see our service running. Okay, and because we're using the Docker desktop driver, okay, Minikube is kind of running in its own hidden environment. But using port forwarding, we can do that. We can, yeah, run this command. Try it also in your terminal. I'll hit enter, and you can see it saying format. It says forwarding from this port to that port. So let's go to the browser and reload. Yeah, this is nice. So Yeah, it is something I had forgotten, but after taking some time to think, I was able to figure it out. Nice. Okay, I want to try to test the self-healing mechanism. To do that, I will try to delete a pod. Okay, so I'll say kubectl delete pod, hit enter. Oh, the no name was provided, so I'll copy this first one and then paste. Okay, says it was deleted. Then I'll clear and run get pods. Are you seeing? Self-healing happened. Okay, this is how important Kubernetes can be. Okay, one pod was killed, but it was automatically uh, given back to life. Okay, so this is how large, huge companies do it with Kubernetes. Yeah, so if you're interested in this, you can go ahead to search on my channel for the tutorial or another channel or documentation on the internet. So in day 15, I can try to show you a CI/CD pipeline with GitHub Actions to test and deploy our code automatically every time we push to the repository. Subscribe and I'll see you there.